Hello everyone. Today we'll be learning a few new formulas to add to our list, and they are the double angle formulas. Now I'm going to show you where they come from, where they're derived. They actually come from the formulas you learned yesterday, which were the sum and difference formulas. Now, in this class we don't have you memorize them. You will be given them on the test. However, in calculus, for instance, you should know where they come from and be able to derive them on your own. So it's really pretty quick. Where this comes from is a double angle can be written as such. We're looking at sine of twice an angle. So when you see 2 next to the x, remember that's not the same as twice sine x. This 2 belongs to the angle. It's saying it's a double angle. This can be looked at as sine of x plus x. You agree that x plus x equals 2x. So therefore, I've rewritten this as a sum, which I can apply this formula that we learned yesterday, the sum of 2 angles. And we can write sine of x cosine of x plus cosine of x sine of x. So essentially, wherever a and b are, I'm just putting x's for every single angle, right? So notice I have sine x, cosine x, sine x. Well, essentially those are the same. We can add like terms. This is equal to 2 sine x, cosine x. Okay, so on your formula sheet that you already have, this is the double angle formula for sine of 2x. So typically when we're working with this, we'll rewrite sine of 2x as 2 times the sine x times cosine x. Okay. Now, the cosine double angle, again, same thing. We're going to think of cosine of twice the angle as cosine of x plus x. And I'm going to go up to where my addition formula is for cosine and plug in x for every single angle. So we get cosine of x minus sine of x, sine of x. Which cosine x can be written as cosine squared x and minus sine squared x. So this is the first formula for cosine of 2x. And cosine 2x actually has 3 different formulas. Now, if you already have your formula sheet in front of you, this is what we're deriving here. We just derived the sine of 2 theta. Sine of cosine theta is cosine squared minus sine squared. Where do these two come from? Well, notice I can plug in for sine 2 theta. I can get rid of this, sine squared theta. I can sub in 1 minus cosine squared. Or for this one, I can plug in 1 minus sine squared and I get the second one. So you can quickly go through those derivations. You actually should on your own. For instance, if I take sine squared and plug in 1 minus cosine squared. We can get cosine squared x minus 1 minus cosine squared x. Distribute the negative. And now I have 2 cosine squared x's that I can add together. 2 cosine squared x minus 1. So this is the second variation for the double angle of cosine. Okay. Now similarly, I can take this same one up here, but instead of subbing in 1 minus cosine squared, I can do it with the cosine squared here. I can plug in 1 minus sine squared x. For that first portion, I still have the minus sine squared x, so those become 1 minus 2 sine squared x. Okay. So again, will we make you derive those in this class? No, but you will need to know those for calculus because you're not given these formulas. You do need to know where they come from. So again, when you're working with double angles, just have these in front of you. This is what you're working with. Cosine has 3 different variations. Okay. And the sine 2 theta just has 1. All right. So I think I'll start the new video for the examples, and we'll go through a few of your examples on your homework sheet.